So you are going to see that whenever you're given an algebraic expression, you are supposed to simplify. Whenever you're given an equation, you're dealing with an equation, you're supposed to solve. So you've got to simplify, you've got to solve. These are two different things that you need to understand. To simplify and to solve. To simplify, there is no finding of any of unknown values, no. It is the equation where you have to find what is the value of the unknown, the value of x, the value of whatever that you're given. All right, so this is a typical exam that you're given that we are going to work with as we are preparing yourselves for the exams that are ahead of time. We are going to work out these typical questions that we have on question number 2. The first part that you're given there was to simplify and leave your answers with positive exponents where possible, which means on this part, all right, you're supposed to leave your answers as positive with positive exponents where possible, where it is applicable, where it is possible. All right. On number 2.11, we are given to simplify this expression of minus a squared b plus 3a squared b, 3ab squared plus 2a squared b minus 4ab squared. That's the expression that you're given to simplify. Remember the part of collecting of like terms. The like terms must be of the same exponent, same letter, same exponent. A squared, this is also a squared, this is b, this is b. So these are the like terms. If you take here, this is a, not a squared. This is a, which is the same as this one, b squared, b squared. So you have to consider that part. So if you consider the like term, they are supposed to be of the same exponent. Same indication that I see is the same indication that I'm having here, this one, same indication. So those are the like terms that you're supposed to consider. So you can even start with this one with a positive. So that's 2a squared b minus a squared b. Same. That is what it's supposed to be like. Which is the same part as this part of 3ab, 3ab squared and minus 4ab squared. This is a, this is a, this is b squared, b squared. So starting with the positive, that is going to be plus 3a b squared minus 4a b squared. So these two, they can be simplified together because you're considering the same thing here. So you simply have to consider your coefficient. What is it that you're subtracting? 2 and 1. So that's 2 minus 1. So that was going to be 1a squared b. But 1a squared b can be written as just a squared b, right? Whenever there's a 1, it's just like 1x. It is the same as x. With the same situation that or the same simplification that we had here, we are going to consider on these last two, which are the like terms, ab squared, ab squared. So we're going to subtract 3 minus 4. So 3 minus 4, that is minus 1. So it was supposed to be minus 1 ab squared. So like I said, guys, this would be just minus ab squared. Minus 1, you do not write that minus 1. It's just the same, like there was a 1 here, there was a minus 1, but you do not indicate that. I'm not saying to indicate that it's wrong. No, there is no need for you to indicate that. So that was the situation. These are unlike terms. Same A, but different exponent. That makes them to be unlike terms. Same B, but different exponents. They are now unlike terms. If they were having same exponents, they were going to be like terms. Like this, a squared b minus a squared b. These are like terms. So it will be 1 minus 1, which is 0a squared b, which is a 0 there. But this one cannot be simplified. At this stage, it cannot be simplified. Okay, let's consider the second part of our question, which is 2.12. Simplify again. That is, this time you have to consider that you've got brackets there. So it's 2 into x plus y plus a 4 into, that's 3x minus 2y like this, minus 4 into 2x minus 3y. So what is it that I'm supposed to simplify? I have to ask myself, what is it? I have got brackets here. So they are numbers, terms that are outside of the bracket, which expand these brackets. A bracket is expanded by the number that is outside of that bracket. Here there's a 2 that is outside of the bracket. Here there's a 4 out of this bracket. Here there's a minus 4 out of this bracket. These are the terms, these are the numbers that are going to affect our brackets. So 2 affect everything in this bracket. 4 affects everything in this bracket. Minus 4 affects everything in this bracket. So let's multiply. 2 times x, that will be 2x. 2 times y here, that will be positive 2y. That's a positive. Positive and positive, so that's 4 times 3. That's a positive 12. 4 times negative 2, you're going to get a negative 8, but there's a y there. So that's minus 8y. Minus 4 and 2x, that will be minus 8x. Minus 4 and minus 3, that's minus, that will be a plus 12. So that's plus 12y. So in this case, you have to collect the like terms. Just like the previous case, you have to collect your like terms. Like terms. So what are the like terms? Those are the ones that you have to collect together. The part of x, the part of y, and so on. So you've got this x and this x and this x together. So you have to consider the part of x only, the part of x on its own. This part of 2, we've got 2x, we've got a plus 12x, the number, and its sign. Minus 8x and its sign, the number and its sign. So what is the sign there? That's a plus. So you're going to add this. So that's 2x plus 12x minus 8x. All right. Then the part of y is the part that is remaining, this one. There's a y there, a y there, y there. Just combine those terms that are remaining. So that's plus 2 plus 2y minus 8y plus 12y. So meaning to say, if we add this, this is going to be 2 plus 12, which is 14. 14 minus 8, which will be 6, or just use your calculator. So that will be 6x. 2 plus this, that's 14 minus this, that's a 6 again. So if you add and subtract, or just use your calculator at once, that will be a positive 6. So that's the simplification. If you want there, you can factor out to say 6 is common. So I'm going to left with 6. I'm going to left in 6 into x plus 1. But it's not necessary. At this stage, you are going to have full marks. Yes, you can factor out 6 because 6 is common. The highest common factor, this part, if you factor it, remain with x. Here, I remain with y. That's the idea there. So these are the expressions that you're given, typical questions. So remember that we are given that you're supposed to have positive exponents. So these are the questions like on 2.13. They were given 2a squared, b cubed, everything to the exponent of 2, then into 2a to the exponent of minus 2, b, everything to the exponent of 3. Then here you are considering 4b to the exponent, that's 4a there. Sorry, 4a to the exponent of 6, b to the exponent of negative 1. So if you are to consider this, you are going to see that there is this part of our law that we need to consider very much. Mn, or let us just consider being raised to the exponent of a. You see that m will be raised to the exponent of a, n to the exponent of a. Every part here will be raised to the exponent of what we are given outside. So what am I simply trying to say is that if there is an exponent, the exponent can affect everything inside of the bracket. The exponent can affect everything inside of that bracket. So in this case, we are simply having a 2 being raised to the exponent of 2. A also, everything is being raised to the exponent of 2. Everything. So that's 2 to the exponent of 2 times, we're going to have a to the exponent of 2 again. So it's a to the exponent of 2 again to the exponent of 2. B to the exponent of 3 to the exponent of 2 again. So that's b to the exponent of 3 to the exponent of 2. All right. Which is the same thing on this part. If you multiply this, you're going to see that 2 is also having the same concept with a, with the b. They are going to be raised to the exponent of 3. So that's 2 to the exponent of 3. Then we're going to have a, which is to the exponent of -2 to the exponent of 3. The b being raised to the exponent of a 3. Okay, so this whole part here is being divided to 4a to the exponent of 6, b to the exponent of -1. So this is it here. Remember that if I have x being raised to the exponent of a, being raised to the exponent of b, exponent on exponent, this will give you x to the exponent of ab. An exponent affects an exponent. You multiply the exponent. This is exactly what is happening here. Exponent, exponent, So all this part, you're going to apply this law. But what about these 2 to the exponent of 2? I can just simplify this 2 to the exponent of 2 on my calculator. That's a 4. So there's no need there. I can just have a 4 times. So here I'm going to multiply exponent, 2 times 2. That's a 4. 3 times 2, which is a 6. All right. Then 2 to the exponent of 3, that will be 8. 2 times 2 times 2. Or just use a calculator. That will be 8 there. So you're going to have 8. A to the exponent of -2 to the exponent of -3, you multiply there, so that will be to the exponent of -6. -2 times -3, that's a -6. Then we've got b to the exponent of 3. Everything here is being divided to 4. A to the exponent of 6, b to the exponent of -1. All right. So even though we know that this is a simplification where we are going to simplify, multiply the numerators together, but somehow you can even simplify some of the other terms, like this 4 and this 4 can cancel. They are the same. It's true that you're supposed to apply your laws of exponents, but sometimes some of the other things you can even simplify. So, okay, this is exactly what is happening. So I can just simplify that. We understand that whenever we are dealing with the exponents, the bases that are the same, to the multiplication, we are going to add the exponents. I'm multiplying x to the exponent of a, x to the exponent of b. I'm going to add the exponents. For the division, we are dividing in this case x to the exponent of a and x to the exponent of b. We are dividing. What are we going to do? We are going to subtract the exponents. So it is clear that in the numerator here, it is a multiplication that we have the a to the exponent of 4, the a to the exponent of -6. They are multiplying each other. So I'm going to add the exponents. So it will going to be 4 plus -6. But take note, already there's an 8 here. I can just consider this number here because there's no other number to be considered. So I can just start by this 8. Then the a is a to the exponent of 4. So I'm considering this part of a here, this a. To the numerator multiplying that. So I'm going to add the exponents. So meaning to say this will be plus -6. But the same a is being divided. There's a division here that we can see. There's a division. There's another a that is dividing here. What are we going to do with that? If we are dividing, what do? We subtract the exponents. So the same a that we are having here, this one, but is in the denominator. So we subtract that one. Because we are dividing, we subtract. So that is the condition. All right. The same thing with the b. We have to consider properly. We can see that there's a b here to the exponent of 6, a b to the exponent of 3, and also a b to the exponent of -1. So just like what we saw from the previous case, that if I'm having something like this, the multiplication here, because these two in the numerator, these two, they are multiplying each other. So we're going to add exponents. 6 plus 3. But what about this one? It is we are dividing there. So we're going to subtract the exponent, which is -1. So we subtract -1. Take note, we subtract -1. So at the end of the day, we are going to see that these being combined together, it was going to be something of this nature. We are going to obtain 8. Let's consider this. This is a plus and a minus. So we're going to obtain a minus. So it's 4 minus 6 minus 6. So that is what we have there. 4 minus 6 minus, or you can just do this. Okay, let me just do this, guys, so that for those who are used to their calculators also, they can see what is happening here. So this is it. 4, a plus and a minus, the minus. So you're going to have -6. Then we subtract also a 6. So that's a -8. So there we are having a to the exponent of -8. The same thing with the b. So there it's a minus and a minus. So we're going to add minus, minus, that's a plus. So meaning to say we are going to have 6 plus a 3 plus, because of minus and a minus, that's a plus. Or you can just do this on your calculator, minus. Then we've got -1, you just open a bracket, minus a 1 like this. The calculator knows everything. Knows how to simplify a minus and a minus. So if you're not supposed to worry about that. So that's a 10. So this will be b to the exponent of a 10. All right, we were supposed to actually have written our answer this way. We could have just written our answer like this. But the question is, are there no laws that can be applied? There are laws of exponents also to be applied. That's why we are given that this must be in terms of positive exponents. Leave your answers with positive exponents where possible. In terms of positive exponents. So this is it. There is a negative exponent. So what am I going to do? I understand this, that a number can be raised to a certain negative exponent. X to the exponent of -n, 2 to the exponent of -3. How do I remove this negative? It is the same as 1 over x to the exponent of n. Just to remove a negative exponent, it's 1 over. 1 or just 1 over like this. I've removed the negative. It's no longer there. There's no longer a negative in the answer. So meaning to say, what is affected there with a negative, it is 8. It is x, I mean the a. Not the 8, not the b. No. No, this part only, this one. It is the part with the negative exponent. So meaning to say, this is going to be given as 8 times the a to the exponent of -8 is same as 1 over a to the exponent of 8. This is not affected. This is not. It is not carrying the negative. No, the negative is on a, not b. No. B is not affected. The b is going to just remain as it is, b to the exponent of a 10. So in our multiplication, we know that all terms can be written as over 1. Every term. Is it x? Is it 1? Is it a 10? Every term can be written as over 1. So this can be over 1, over 1. So what does it mean? I'm simply multiplying the numerators together. 8 times 1 times b to the exponent of 10. That is going to be 8b to the exponent of 10. 1 times 8 to the exponent of 8 times 1, that is a to the exponent of 8. That's it. In terms, the answer should be positive. We are supposed to have positive exponents on our answer. Positive exponents on our answer. So that's the idea then. So you're supposed to be careful in the simplification. So there I'm just trying to show you guys like stage by stage, but some of these other stages, they are not even like necessary to show you. Just have to just be careful on which steps are very, very important whenever you are simplifying. All right, on 2.14, we have got a similar question again, where we need to simplify and also leave our answers as positive exponents. That's 2.14, where we are given to simplify the cube root of negative 27, x to the exponent of 3, everything over a 64. So that's the cube root of this. All right. So it follows that we can simplify the cube root of numbers. Even the cube root of a negative can be simplified. So what am I trying to say? We can see, guys, even if you do not know, no one is going to know that you have used a calculator. You can just simplify the cube root of this like this. The cube root is this one. The cube root is this one, or above the square root. So it's shift above the square root. That's the cube root, this one. So it's the cube root of negative 27 like this over 64. This is you and your calculator. You get what? 3 over 4, minus 3 over 4. So meaning to say on the top there, I've got a minus 3. In the denominator, I've got what? A 4. But remember, there's supposed to be x to be affected. So how do I find the cube root? That is the question now. How do I find the cube root of this x to the exponent of 3? How do I find that? So it follows that the nth root, if I'm given something like this, the nth root of x, like this, if I'm given something of this nature, to the exponent of m is the same as x to the exponent of m over n. So what am I trying to say? If I'm given the nth root of x to the exponent of m over n, this exponent is the numerator. This number inside of the root sign is your denominator. So let's use this to simplify the cube root of this part that is remaining of x to the exponent of 3, because we are remaining with a variable there, x to the exponent of 3. So it means x to the exponent of 3, which is our m, which is this 3, over n. Our n is the number inside of the root sign, which is the 3. So we are going to have x to the exponent of what? A 1, which is just x. So meaning to say in the numerator there on top, I have got what? X. So it's going to be minus 3x over 4. What am I trying to say? Okay, this is it here. I'm trying to say that the cube root of x to the exponent of a 12, from that law that we had, that is the nth root of x to the exponent of m, which is x to the exponent of m over n. It means that we are having x to the exponent of m, which is the exponent there, which is 12, over what? Over n, the number inside of this, the root sign, which is the 3. We consider the cube root. So this will be x to the exponent of 3 into 12, that is a 4. So meaning to say the cube root of x to the exponent of 12 is x to the exponent of 4. So you can find the square root, you can find the cube root, you can find whatever root sign from that law. And these are positive exponents. So meaning to say there's nothing that I can do from this. It's done. All right. So that was just 2 marks for that. As you can see, it was fine for 2 marks. Let's consider the other question. 2.2. Solve for x by using the following. Solve for x by solving the following exponents. All right, they were just supposed to say solve for x, but this is not an exponent, this is an equation. By solving the following equations, not exponents, guys. All right, let's just say equations so that we understand each other. These are equations that you're supposed to solve. The first equation, we're given 5 into x minus 2 is equal to 3x minus 4. That's a linear equation. The highest exponent that we have, it's a 1. So how do we solve? We have to consider to solve, find the unknown, find the unknown value. That is to solve. You have to find what is unknown, and what is unknown, it's x. What is x in this equation? What is x in this equation? So there's a bracket. So expand the bracket. So here you need to expand the brackets. So to expand the brackets, what are you going to do? Expand by the number that is multiplying the bracket, which is a 5, this number here, outside of the bracket. The number in contact with the bracket. So 5 times x, this is the same as 1x. So it's 5 times 1, which is 5x. 5 times a negative 2, that's a negative 10, which is equal to 3x minus 4. So from there, we can collect the like terms, the part of x to one side of the equation. So that means I can take this 3x to this side of the equation, the negative 10 this side, but taking note, once a term, a number crosses the equal sign, it changes its sign. So I was having 5x here originally, so it's not going to change. But the 3x, the moment it crosses the equal sign to come this side, it is changing its sign. It was a positive, so it will be minus 3x. So this is equal to, already on the right-hand side, there was a minus 4 here. It was already on the right-hand side. So I'm going to write that one. Then I transpose the negative 10 to that same right-hand side. It was a negative. So the moment it crosses the equal sign, it crossed the equal sign, it becomes a positive. It was a negative, it's going to be a positive. So that's it. You can subtract on your calculator 5 minus 3, which is 2x. So this is equal to negative 6, negative 4 plus 10, which is a positive 6, just like 10 minus 6. So this is the same as 10 minus 4, which is a positive 6. So you can even use your calculator in the simplification. If you're having any confusion on that part, minus 4 plus a 10. So this is negative 4 plus a 10. That's a positive 6. So meaning to say we can now find the value of x. How are we going to find the value of x? Take note, it's a multiplication that we are having here. 2x means 2 times 2 times x. So how do I find the value of x? How do I remove the 2 that is multiplying? Opposite of multiplying is to divide. So the moment you divide both sides, you are finding this x, which means we are now remaining with x, and 6 divided by 2, that's a 3. So we are having the numerical value of x. It means x is represented by 3 in this equation. So what does it mean? It means if I take this value of x and try to prove this, I'm supposed to have the left-hand side must be equal to the right-hand side. That is what it means. The left-hand side must be equal to the right-hand side. So this is 5 into our x. Remember, we solved our x is 3. So this is going to be 3 minus 2, like this. So this must be equal to 3 into x. Remember, our x is 3. So it's going to be 3 times 3, like this, minus 4. So that's it. So this must be equal to this. That is, if truly this x is correct, the x that we are saying, it is equal to what? It is equal to 3. So there, I'm just going to need a calculator. This is to prove, guys. This is not part of a question. I'm just need to prove this. So I just need a calculator there. So that's 5 into 3 minus 2. So we are going to have a 5. So from the left-hand side, we are obtaining a 5. Let's see the right-hand side. That is 3 into 3. 3, open a bracket, then subtract a 4 like this. That's a 5. So as you can see, the left-hand side and the right-hand side are directly the same. So that means this value of x that we have determined here is correct. That is how you can see that, all right, this is correct or not. So you just need to work with more questions there. Just try to revise as much questions as you can. On 2.22, this was actually an exponential equation. 3 to the exponent of x minus 1 is equal to 81. So whenever you're given this type of an equation, try by all means, because you have got a base being raised to an unknown exponent, which is x. So try by all means to have this condition of a base raised to a certain exponent is equal to the other base raised to another exponent, as long these two are the same. If these two are the same, x and x, it follows that a will be equal to b. The exponents will be equal. If the bases are the same, automatically the exponents will be equal. By default, your exponents will be equal. So 3 is a prime number. So meaning to say 3 is in simplest form. A prime number, you're considering a number that is in simplest form. Sorry for that. Prime number is it's already in simplest form, this 3. Simplest form. So it means there is no other number that I can think of to say I can reduce this to an, no, it's already in simplest form. So the number that I'm supposed to think of is this 81. How can I write this 81 in terms of this number, which is already in simplest form, which is 3? In the base of 3, 81 is same as 3 to the exponent of 4. So let's say I do not know this. How am I going to find out? I can test this on my calculator, because let's say I do not know the exponent there to use. Just test 1 until you get 81. You know that you are supposed to be in the base of 3, because 3 is the simplest number. Because guys, you want the bases to be the same. You want x and x. So already here there's a 3. So you want to write 81 as a number in base of what? As a number in base of 3. So you try 3 to the exponent of 2, that's 9, which is not 81. You try again, 3 to the exponent of 3, which is 27, not 81. You try again, 3 to the exponent of 4, that's 81, until you get 81. So you know that this 81 is same as 3 to the exponent of what? Of 4. Once you can see that, therefore, it means the bases are the same. Because you can see, therefore, the exponents are the same because of this 3 and 3 concept. The bases that we see here are the same. So automatically, the exponents will be equal. Automatically, the exponents will be equal. Meaning to say, x minus 1 will be equal to 4. So transpose the negative 1 to the other side. That's a positive. So x will be equal to 4 plus 1, which is a 5. Just like that. So these are the typical questions that you are going to be asked. And it's very, very important that you do revise along these typical questions to understand an equation, to understand an exponential equation, to understand a linear equation like this one. All right. Another equation is given 2.23. Solve again for x. X over 3 plus x over 4 is equal to 1. So if I'm to consider this, I'm going to see that, all right, I have a fraction. So this also can be written as a fraction. Every number can be written as a fraction by just dividing by 1. 1 over 1 is a fraction. So what do I need is to clear these fractions, to remove the fractions, to clear the fractions. So to remove the fractions that I'm given here, or to clear these fractions that I'm having, I have to multiply each and every term by the LCD, the lowest common denominator, or the LCM. That is the LCD. So what is the LCD of 3, 4, and a 1? The number that we are going to use there to say, okay, if you multiply that, I mean, that is the lowest common denominator. It's a multiple. If we divide by that number, we do not even have a remainder. Like that number divided by 3, we get a whole number. That number divided by 4, there must be only whole numbers that you're getting there, exact values. So you see that the LCD of this, or the lowest common multiple, is a 12. Remember how you find the LCM? You're given 3, 4 is same as 2 squared. So the LCM is just going to be everything that you have there, which is 2 squared times 3, and that will be 12. So you multiply this by the LCD, each and every term. You multiply each and every term by the LCD, each and every term by the LCD. So 12 is same as 12 over 1. So this is same like over 1. So what you're simply doing is 3 into 12 is what? It's 4. Or 12 divided by 3, that's a 4. Then 4 times x, you multiply 4 and x. So that will be 4x plus 4 into 12. So 4 into 12, that's a positive 3. So 3 times x, that will be 3x, is equal to 1 times 12, which is 12. Just like that. So here I've got like terms, x and x, to be considered, same exponent. So we're back now to the addition where we talked about that we simply have to add the coefficients of x. The coefficients of x. So meaning to say I'm just going to add 4 plus a 3, which is 7. So that's 7x is equal to 12 divided by 7 on this part. Like this, we're going to divide by 7. So that means we have got the value of x. So x is going to be what? Cancel this part here. X is going to be 12 over 7. That's it. So you have to be careful. You're supposed to be very, very careful in your simplification. So someone is asking like, how, what if I just added these two, because these two fractions are being added together? What if I just added these two fractions? This is x over 3 plus x over 4, which is equal to 1. Considering that 3 and 4 are different, so you have to find the LCD so we can add this, which is 12. 12 divided by 3, remember your addition, that's 12 divided by 3, which is 4. Then 4 multiplies x. So it's going to be 4 times x, which is 4x. So that one is just 4x there. Plus 12 divided by 4, which is a 3. Then 3 times x, which is 3x. So this is equal to 1. So collecting your like terms, already there's 4x and 4x here, 4x and 3x. So 4 plus 3 plus 7x over 12 is equal to 1. So since I have a single fraction and another one can be written as a single fraction, I can solve this equation by what is called cross multiply, because there are two fractions. Cross multiplication is not applied here because there are 3 terms. It's a term, a term, a term. Cross multiplication is only applicable when you've got this condition: a single term on one side of the equation, another single term on one side of the equation as fractions. So that means we can multiply 7x times 1, which is 7x, is equal to 12 times 1, which is 12. So dividing by 7 both sides, that means I'm having the exact value of x, which is what? Which is 12 over 7. Which is the same thing, just like the previous case that we had. Same simplification. So whenever you are to solve an equation, to solve means you are to determine the exact value of the unknown. What is the value of x? And you can prove that with the value of x that you have into the equation. So you just have to be careful on that one, like I said before. All right. Another part we are given on 2.3, determine the value of this expression, x squared minus 2xy to the exponent of 3. All right, this is inside here. This is inside. So it's like this. 2xy like this to the exponent of 3. So the question is, determine the value of this expression if x is minus 1 and y is 2. All right. So what does it mean? In place of, you're just substituting. You're just making a substitution. Where there's an x, you substitute minus 1. So that's minus 1 to the exponent of 2. Minus 2 into, so that's a multiplication there. Our x, which is minus 1, times y there, which is a 2. So everything will be raised to the exponent of 3. All right. So negative 1 to the exponent of 2, that one is just going to be positive 1 on your calculator, or negative being raised to an even number, it becomes what? A positive. So you're going to have a negative, this one. So according to this, you have to simplify what is inside of the bracket first. This part inside of the bracket first. So that's 2 times negative 1 times a 2. So there we are going to obtain a negative 4 being raised to the exponent of 3. There's still an exponent. And this exponent is not affecting anything but this minus 4, only minus 4, this one. So on your calculator, minus 4 to the exponent of 3, that is going to be minus 64. So meaning to say we are now having a negative, which will be a positive. So 1 plus a 64, that is going to be a 65. So if you add this, 1 plus a 64, that is going to be a 65. So this one, you can just even use a calculator there to simplify. It's not a problem as long you have substituted properly. Simplify this, use a calculator, simplify this, write it down, use a... So each and every stage, write it down. It's true that you're using your calculator, but write down whatever that you're getting. Write down each and every stage. So this is just a substitution where you have to substitute the equivalent value of what you're given in place of that value. In place of that part, is it x? Is it y? So these are the typical questions that you'll be having in your final exams. So let's revise as much as we can. As we can see, this is question 2, 21 marks, meaning to say you're almost there, having 21 marks. If you just revise these questions, you can actually obtain these 21 marks that you see there. So more questions to come from Maison African Motives till we meet again.